All right, so it says determine a scale you can use. Okay, so what the one possible answer is changing everything to inches, not feet, and then using a scale of 1 to 12, but that doesn't work. So 1 to 24 would work. If you left everything in feet, then 1 to 24 would be if you did things in inches, which you may or may not have done. Really, if you did a centimeter to a foot or something as your scale, that wouldn't be a bad way of doing it. See, yeah, okay, that's probably a good way of doing it. So that's kind of one approach you can take. B says, okay, so I'm just going to go right down to an example of what the scale diagram could look like, and it could look like this. If yours looks anything different, did you do it wrong? Not necessarily, okay? Some people like to spend a lot of time rearranging their house, making everything look perfect and, changing things up and stuff. And there's some people that are really talented at it and spend a lot of time doing it. Some people just care about finding spots for everything, and then that's fine too. But so if yours still looks a little different than this is okay. Basically, you just want to be able to have something that looks reasonably similar to this. Okay? All right. Okay. I don't really care about that stuff too much, other than I'll say this scale factor. So if your scale could have been, like I said, the scale could have been 1 centimeter to 1 foot. That would have been probably the scale I would have used. Okay. But a scale factor is a little different. The scale factor is not a ratio, it's just a number. So what the heck is a scale factor? If a scale factor is 1/16, say, what does that mean? That means that everything on your diagram is 1/16 the size of what it is in the real world. So if you're given the measurements of the walls, you're given the measurements of the couch, the love seat, the entertainment unit, you would divide all those measurements by 16 and no doubt change them into inches and then draw them in inches. Okay? So when you have a scale factor of 1/16, that means you would divide everything by 16 to get how big it needs to be on your picture. Okay? Good enough. So a builder plans to construct a house on a rectangular lot as shown in this sketch. Draw a scale diagram of the lot and house using a scale of 1 meter to 500 meters. So basically what we have to do is we have to, so 40 meters by 10 by 15 meters. So all you need to do is take these and divide these by 500. And if you divide this by 500, you're going to get 0.08 meters, which is 8 centimeters. If you divide this by 500, well, then you're going to get 0.03 meters or 3 centimeters, and so on and so on. So if you're going to draw a diagram of this with a scale of 1 to 500, you're going to divide these all by 500, and what you're going to end up with are measurements that are inevitably in centimeters, and then draw those diagrams on a piece of paper. All right. So when you're drawing a scale diagram, you do have to keep in mind what the scale is, and you have to apply that scale to each of the measurements in the picture. Okay, so you have to divide them all by 500, and then to make your life easier, consider them in centimeters so you know how to draw them with a ruler. Okay. Same thing there. Now this says Joe wants to do using a scale of 0.01. So that's a scale of 1 to 100. So his is going to be a lot bigger. In fact, it's going to be 5 times as big. Explain how this diagram would differ from Eric's diagram. Well, it'd just be every measurement would be 5 times as big, and the area itself would be way, 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 way bigger. Okay. Here's another example. Jess designed the logo shown for an environmental club. She wants to enlarge the logo to make it bigger so it can be put on the front of a ball cap. The hat company has suggested a scale factor of 5/3. Draw a scale diagram of the logo as it'll appear on the ball cap. So how would we do this if we were drawing this like you guys? How would you do this? Okay. Well, what you're going to do is this. All right. So with your rulers, you could find the radius or diameter of these circles. Okay, you could find the radius or diameter of these circles. And if you're going to use this, and let's say, can someone actually measure what the diameter is of this big circle? The diameter of this big circle? Okay, that one. Yeah, 2.5 centimeters. Okay, so if it's 2.5 centimeters, okay, how do we deal with that and the scale factor? Well, all we do is we take 2.5 and multiply it by 5 over 3. So if you take 2.5 and multiply it by 5 over 3, what you should get, if my math is okay, is 4.166666666. Okay? And if we're going to round that, which we should, it would be 4.2 centimeters. So this would represent the new size of the diameter of the big circle. Okay? And we'd also have to do the same thing with the diameter of the small circle. Okay? Whatever the diameter is of the small circle, we have to multiply that by 5 over 3 as well, and then do that. And then what we would need to do, because we're drawing circles, is I would need to give you guys a compass so you can draw a circle, but the compass would help us find the radius. So we'd have to divide each of these diameters by 2 to get the radius is, and then we would just draw a circle with that radius, and then we're all set. Okay? Right? Does that kind of make sense? We get, so for 4.2 centimeters, we would have to measure with a compass this distance. It'd be half of this, so it'd be 2.1. So we would separate it to a distance of 2.1 centimeters, draw our circle, right? Then we'd have to do the same thing with this inner circle. Find its diameter, divide it by 2 to find the radius, and then draw it with a compass. And then we can draw on those 3 lines. We wouldn't have to measure those 3 lines because those 3 lines represent the radius of the inner circle. The radius of the inner circle. So we would just draw, we would probably try to draw them correctly. Like you could measure the angles, but I would bet dollars to donuts that these are all 120 degrees. So it's 3 equal parts of a circle. So you would just probably just try to, with your protractor, make sure to draw or divide up your circle into 3 equal pieces, just like it is there. Make sense? Like we would not want something in the center. We would not want something in the center that looked like this. So pretend this was the center, okay? We wouldn't want something that looked like this. Well, first off, that looks like a piece of, okay, something like this. Okay, that's not obviously, those aren't 3 equal pieces, right? Right? It looks kind of crappy. So we want to be able to make sure that it looks as close to the original product as possible. Now, I'm not going to have you guys actually draw it out. I just want you to see how we would go about it if we were going to draw it out. Okay? This thing says Jess initially thought of using a scale factor of 400%. What the heck does it mean if it's written as 400%? Well, if we think of 100% as one whole, then 400% is four wholes. In other words, what we're doing is if we have a scale factor of 400%, we're actually making it everything 4 times bigger. All the lengths are 4 times bigger. Now, it does say to draw the logo using that scale factor. We're not going to do that, but it says part B, why do you think she decided to use the recommended scale factor? The recommended scale factor was 5/3, and that's only about, well, it's 1 2/3. So I'm guessing that if you multiplied it by 4, it'd be a massive logo. And even if it would still fit on the hat, you probably, with a hat, you don't want the whole hat, the front of the hat to be the logo, right? You don't want the whole front of the hat to be the logo. You want there to be a little bit of black space or white space or space around the logo. You don't want the whole hat to be the logo, okay? Okay. Um, another example. Another example. The diameter of the animal cell that's represented by the scale diagram is actually a 1/4 millimeter. What scale factor was used to draw the scale diagram? So if the actual cell is only a 1/4 millimeter in diameter and the picture is 3.5 centimeters long, then the scale picture is an enlargement, okay? Obviously, if you were looking at a cell of an animal, it's not going to be this big, right? Cells are tiny, tiny things. I lasted a week in grade 11 biology, and even I know that, okay? Even I know that. Cells are not that big. So to figure out what kind of an enlargement it is, we have to divide the 3.5 centimeters by 0.25 millimeters. But when we divide them, what we should do is we should make sure they're both in the same scale. They both have to either be in millimeters or centimeters. So that's easy enough because 3.5 centimeters is 35 millimeters. So I'm going to take 35 millimeters and I'm going to divide it by 0.25 millimeters. And when I do that, I should get 140. So what that means is that the diameter and any other kind of measurement of anything inside, like the mitochondrion, the nucleus, the cell wall, or whatever else is in an animal cell, is going to be 140 times bigger than what it would be in real life. Okay? What it would be in real life. So that would be like saying that these mitochondria are actually 140 times smaller than this in real life. Okay? And that's why we look at those kinds of things through a microscope. That's right. They are naked to the human eye. Okay? Um, explain why it makes sense that the scale factor used for this scale diagram is greater than 1. Because cells are tiny, right? Cells are tiny. So if cells are tiny, we're not going to be able to see them with our eyes. So we need to blow them up and make them bigger so we can see them and understand them and see how they work and all that jazz. Okay? So here are just some final thoughts before leaving you to do some work. Scale diagrams can be used to represent two-dimensional shapes. We need to find an appropriate scale to use. This depends on how big of a diagram we can make or need to make and the dimensions of the original shape. The scale factor represents the ratio of a distance measurement of a shape to the corresponding distance measurement of a similar shape, where both measurements are expressed using the same units. So if we're talking scale factor, they have to be in the same units because we divide them. If we're talking scale diagram, like we were when we were talking scale diagram, but if we're talking about a scale, like we were when we did the whole living room thing, when we had to do that diagram, we used a scale and we said 1 centimeter to a foot, and that's perfectly fine. But if we want to write it as a scale factor, or we need to find a scale factor, then they both must be in the same units. Always, 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 always. You can multiply any linear dimension of a shape by the scale factor to calculate the corresponding dimension of a similar shape. When figuring out the scale factor, we take the diagram measurement and divide it by the actual measurement. And if the scale factor is between 0 and 1, then the scale diagram is a reduction of the original shape, or it's smaller than the actual shape. And if it's bigger than 1, then the scale diagram is larger than the actual shape, and it's called an enlargement. Such was the case when we looked at the cell and the logo. Okay? So for homework, just do the questions that follow in section 8.3. I don't know exactly how many of them there are, but work through them, and they'll get you ready for Monday.